Let's solve this GATE 2001 question. Relation R A B C D is a relation. Which of the following does not have a lossless joint dependency preserving BCNF decomposition? See, there are four functional dependencies given to you. Basically, there are four relations given to you. Okay, you have four relations, this relation, and so on. Four relations are given. Now we have to find for which of these relations does not have any decomposition, which is lossless and dependency preserving BCNF decomposition. Okay, this is what we need to check. So let's start. Now, let me start with the first one. Let me check. Okay, see this first one. The first one has, you have a relation R A B C D. This is your relation, and the functional dependencies are A determining B, B determining CD. First of all, you tell me, is this in BCNF? Let me know. First, you check, is this in BCNF or not? Let me know. See, from here, you can easily see what are the candidate keys. What will be the candidate key? Please tell me. The candidate key is A. So this is a violation. Yes or no? This is a violation of BCNF. Okay, very simple. So definitely this relation, this option A, this is not in BCNF. Okay, this is not in BCNF. So decompose. Yes or no? So what we will do? So we will decompose into BCNF. This is what we need to do. Correct? Because this relation is not in BCNF, so we decompose into BCNF. Now let me tell you the BCNF decomposition algorithm. In our lectures we have already seen, but let me quickly tell you again. What is the BCNF decomposition algorithm? Do you remember? Do you remember the BCNF decomposition algorithm? Let me quickly tell you. So if R is not in BCNF, okay, if R is not in BCNF, remember, if R is already in BCNF, then will you decompose? If relation is already in BCNF, then will you decompose? No, there is no need of decomposition. Yes or no? If the relation is already in BCNF, then that relation itself is BCNF, so there is no need of decomposition. Okay, so if R is not in BCNF, then there will be violation. Okay, yes or no? Then take any violation. Very simple, take any violation. Take a violation. Okay, there can be many violations. So what you do, take a violation, any violation you take. For example, this type of violation, X determining A, this type of violation you take. Okay, so here this is a violation, it means this is not a super key, because this is a violation of BCNF, so this is not a super key. Now what you need to do, now you need to find X plus. Basically what you need to do, now you need to decompose. Okay, you need to decompose R into R1 comma R2. Okay, what will be R1, what will be R2? Let me tell you. The R1 will have X plus. Very simple. In the R1, you will put X plus. Okay, find X closure. See, this is the violation. In this violation, what you do? Find the closure of LHS. And what R2 will have? R2 will have, from R, you remove X plus, but you add X. Okay, means you remove this X plus, but you add this X. This LHS you add. Okay, so this is the BCNF decomposition algorithm, very simple algorithm. Okay, so this algorithm you can apply here. Okay, let's apply this algorithm here. So let's decompose into BCNF. So this is the violation we found. Yes or no? So what you will do? Decompose. Very simple. What you will do? You will find B plus. Okay, take violation. Take a violation. So you can easily see that we got this violation B determining CD. Take this violation. Okay, now what you are going to do? You will find B plus. So B plus will be BCD. Okay. Now what you will do? Now this R, now this relation R you will divide into R1 comma R2. What R1 will have? R1 will have this BCD. Okay, I told you that if you have a violation, then you find X plus, you find this X plus. This X plus will be one relation, and the another relation will have all the attributes minus X plus X. Okay, don't remove these attributes. Okay, these X attributes, don't remove them. So very simple here. So this BCD will be going to R1, and in R2 what you will get? In R2, remember, from R remove BCD. From R, you remove BCD. What you will get? From R, you remove BCD. What you will get? You will get A. Okay, but add this B, add this X. Okay, so finally you will get AB. Now you check. Now what you do? Now you check. Remember, after you do this decomposition, now you check R1, R2 are in BCNF or not. Okay. Now check R1, R2 are in BCNF or not. Okay. Is this clear? If they are not in BCNF, then what you will do? If any of them is not in BCNF, for example, if this is not in BCNF, then what you will do? Then repeat the same procedure. Then repeat the same procedure. Okay. Very simple. Then again decompose, then further decompose. So here you tell me, did we get BCNF? See, this is definitely in BCNF because only two attributes. Nothing to check. Every relation with two attribute is in BCNF. So this is definitely in BCNF. Okay. What about this? Is this in BCNF? Yes, this is also in BCNF, right? Okay, this is also in BCNF because in this you only have this FD. Okay, in this R1 you only have this functional dependency. Only this functional dependency we have. So you can see this R1 is also in BCNF, right? And can you notice, is this lossless? Is this lossless? Let me know. Check. Check if it is lossless or not. Please tell me. See, BCNF is done. Now you check lossless or not. Yes, this is lossless. Okay. Yes, this is lossless. You can see the set of common attributes is B. And you can see this B is a super key in R1. So this is lossless. Is this dependency preserving? Is this dependency preserving? You can see this dependency is preserved here. This dependency is preserved by R2 and this dependency is preserved by R1. So yes, this is dependency preserving also. Okay, is this clear? So we have done this part A. So this option A, for option A, definitely possible, yes or no? For option A, BCNF decomposition with lossless and with lossless join and dependency preservation possible. Okay, is this clear? So remember, the question is asking does not have. So definitely this is not the answer. Option A is not the answer. Is this clear? Option A is clear to everyone. Please tell me. See, very simple. This is your option A. We already know this is not in BCNF. What we did? First, we are finding is this in BCNF or not? This option A. We found that this is not in BCNF. So what we will do? We will decompose into BCNF. We can apply this BCNF decomposition algorithm. What this algorithm will do? It will take a violation, take this type of violation of BCNF you take. Then what you do? You find this X plus, that will be your subrelation R1. And in R2, what you will do? You will put from R, you remove this X plus, but you add this X. Okay. But you add this X. Very simple. Then what you will do? You will again check, are they in BCNF? Is this BCNF? Is this BCNF? If they are not in BCNF, for example, if this is not in BCNF, then you will further decompose. Then again, you will do the same procedure. Okay, so this is the BCNF decomposition algorithm. For this option A, we can apply the BCNF decomposition algorithm. This is the violation. This is the violation of BCNF. So we will take this violation and you can see this is the decomposition we will get. Here you can easily see this decomposition. This is lossless. This is dependency preserving. And also this is BCNF. Both are in BCNF. So definitely I can say that for this option A, BCNF decomposition with lossless join and dependency preserving possible. Okay, now let's see option B. Now tell me about option B. Each option we will see one by one. What about this option B? So let's look at option B. We have this relation R, A, B, C, D. And the functional dependencies are A determining B, B determining C, C determining D. These are the functional dependencies. Okay. So first you tell me, is this in BCNF? Let me know. First you check, is this in BCNF or not? What are the candidate keys? See, there is only one candidate key, that is A. So definitely this is not in BCNF. Yes or no? This relation is not in BCNF. Okay, what are the violations? This is violation. This is violation of BCNF because this B is not super key. Similarly, this is violation of BCNF because this is not super key. Okay, is this clear? Both are, these are violations of BCNF. This is not violation. Okay, yes or no? This is not violation because here A is super key. Here you can notice that A is super key. Okay, so what you will do? This relation is not in BCNF. So what are you going to do? Please tell me. So decompose. So decompose R into BCNF. Okay, this is what we need to do. Decompose into BCNF. So what you will do? Take a violation. Take any violation. Take a violation. Okay, which violation you will take? Any violation you can take, remember. Okay, for example, you can take whatever violation you want to take. For example, let me take B determining C. Okay, take this violation. Take a violation. What you will do? You will find B plus. What is B plus? B plus is BCD. Okay, so now what will happen? This relation you will divide into R1, R2. What R1 will have? R1 will have B plus. R1 will have BCD. What R2 will have? What R2 will have? From this, you remove BCD. What you will get? You will get A. But you add this X, this LHS you add. So you will get finally AB. Okay, is this clear? But here you notice one thing, that this is in BCNF. This is in BCNF, right? Yes or no? This is in BCNF. And what about this? Please tell me, what about this? Is this in BCNF? This is not in BCNF, right? This R1 is not in BCNF. You can easily see. Because in this R1, okay, let me focus on R1. So we got this R1, R2. Remember, R1 we got, that is BCD. This is the R1 we got. And R2 we got is AB. Okay. Now here, this is already in BCNF because only two attributes. So this is in BCNF. Every relation with two attributes is in BCNF. Okay. This is not in BCNF. Why this is not in BCNF? Because just see what are the functional dependencies in R1. In R1, we have B determining C, C determining D. So what are the candidate keys? Candidate key is B. So this is the violation. So this is the violation of BCNF. Now what you will do? Now you will further decompose. Okay, very simple. So take this violation. So take this violation C determining D. Find what is C closure, that is CD. Then what you will do? Then this R1 you will further decompose. Okay, R1 you will further decompose into CD. Yes or no? You will further decompose into CD and BC. Okay, is this clear? Simple. Now you can see this is BCNF. Now you can see this is BCNF. So finally we got BCNF, BCNF. Yes or no? Is this clear? So remember, this was your original relation ABCD. Okay, and these were the functional dependencies. A determining B. This was our original relation. B determining C, C determining D. We got decomposition. Okay, we got R1, R2, R3. R1, what was R1? So you can see basically this is what we got. A, B, C, D, B, C. Okay, we got A, B, C, D, B, C. A, B, B, C, C, D. So this is the decomposition we got. Is this clear? Let me know. We got this decomposition. This is a BCNF decomposition, BCNF. Okay, this is a BCNF decomposition. Now here, this is in BCNF, this is in BCNF, this is in BCNF because every relation with two attribute is in BCNF. Now, can you notice, is this dependency preserving? Is this dependency preserving? This dependency preserved by R1, this dependency preserved by R2, this dependency preserved by R3. Yes or no? So this decomposition, this is dependency preserving. This is dependency preserving. Also, this is lossless. Okay, so this is, you can see all the three properties are there. This is BCNF. All of them are in BCNF, and dependency is preserved. this dependency preserved by R1, this dependency preserved by R2, this dependency preserved by R3. Yes or no? So you can see, and this is lossless. So all the three properties are satisfied. So again, you can see this has, remember, for this, for this option B, for this relation, what I can say, there exists, there exists decomposition. There exists decomposition. Okay, there exists decomposition which will have all the three properties. It will have this property also, it will have lossless property also, and it will have dependency preservation property also. Okay, is this clear? Very simple. What about the next? First, you tell me option D. Let me know about option D. Tell me, what can you do about option D? Tell me, this is your relation R, A, B, C, D, and the functional dependency that is given to you, that is A determining B, C, D. First, what you will do? First, you will check, is this in BCNF or not? Let me know. What are the candidate keys? A is the candidate key. This is already in BCNF. This is already in BCNF. Okay. Is this clear? This is already in BCNF, so there is no decomposition required. Or I can say, this itself is decomposition. This itself. Okay. Basically, either I can say no decomposition required, no BCNF decomposition required. No BCNF decomposition required. Or I can say, that this R itself is BCNF decomposition. This R itself is BCNF decomposition. R itself is a BCNF decomposition of R. Correct? Okay. So R is BCNF decomposition of R. So there is no decomposition required. So again, I can say that. Okay. So because no decomposition required, so there is no point of lossy or not preserving decomposition, not preserving the dependencies. Yes or no? So you can see this is in BCNF. Okay. There is no point of lossy. This is already lossless. Okay. This is already lossless, and this is dependency preserving. Yes or no? All the three properties are there for this option D. Okay, very simple. Now, if you are in the gate exam, then which option you will take? Tell me. If you are in the gate exam, then the only option that is remaining, that is option C. Yes or no? But now let's see option C. Option C does not have any decomposition which will satisfy all these three properties. Okay, so let's see option C now. The last option is remaining, option C. That is AB determining, this is your relation R, A, B, C, D. And these are the functional dependencies. Functional dependencies are AB determining C and C determining AD. First, to tell me, what are the candidate keys? First, to check, is this in BCNF or not? Okay, for this, you find what are the candidate keys. Tell me what are the candidate keys. You can see AB is a candidate key. BC is a candidate key, right? Yes or no? AB, BC, they are the candidate key in this. Okay, very simple. So tell me, what is the violation then? AB, BC, they are the candidate key. Then what is the violation then? This is the violation. This is the violation of BCNF because C is not super key. This C, this is not super key. Okay, so this is the violation of BCNF. So definitely this option C, this is not in BCNF. Okay, if this is not in BCNF, then what you will do? Then you will decompose. You will decompose into BCNF. Okay, what we will do? We will decompose this relation R into BCNF. This is what we are going to do. Okay, now one thing I want to tell you, you can apply the BCNF decomposition algorithm. Let's apply. Okay, then one important thing I will tell you, how to check whether we can preserve the dependency or not. Okay, that I will tell you. But let's apply the BCNF decomposition algorithm. Okay, just apply the algorithm. Is this clear? So we will decompose into BCNF. Now, if you want to decompose into BCNF, then what you will do? You will apply the algorithm, take a violation. Okay, so let me take a violation. Okay, this is the violation C determining AD. This is the violation, so take this violation. Now what you will do? Now you will find C plus. C plus will be what? C plus will be AD. Now what is your next step? Your next step is this R you will decompose into R1, R2. This R1 will have ACD, and what R2 will have? From R you remove ACD, so you will get B. Okay, you will get B, but you add this LHS. You add this LHS, so you will get BC. Now this is in BCNF, there is no doubt. Yes or no? There is no doubt this is in BCNF. What about ACD? What about ACD? Is this in BCNF? Let me know. What about ACD? Is this in BCNF? Yes, this is also in BCNF. Yes or no? This ACD, this is also in BCNF. Okay, you can check. What are the FDs? What are the functional dependencies in ACD? In this R1, what are the functional dependencies? Okay, this is the functional dependency. Correct? Is this clear? Okay, this is the functional dependency. That's it. Now you can easily see that this is in BCNF. This is also in BCNF. This is also in BCNF. Is this lossless? Yes, this is lossless because the set of common attributes. What is common? C is common. And you can see this C is super key in R1. This C is common and this C is super key in R1. Is the dependency preserving? Is this dependency preserving? No. Which dependency is not preserved? Tell me. You can notice this dependency is gone. AB determining C. This dependency is not preserved, right? Yes or no? R1 union R2, they do not preserve this dependency. Yes or no? Dependency preservation is not there because you can see AB determining C lost. Is this clear? Please tell me. Let me know. Did you understand this? So very simple. We got BCNF decomposition. It is lossless, but you can see this dependency is lost. Okay. Now you might be thinking, see, at this point, can I say there is no decomposition which will have BCNF lossless dependency preservation? Tell me. Tell me, tell me. At this point, can I stop and can I say that there is no decomposition which can give me these three properties? BCNF lossless dependency preservation. Can I stop and can I say that there is no such decomposition? I cannot stop because please understand, so far only one algorithm I applied. Please understand. Here what I have done, I have applied only one algorithm. See, only BCNF decomposition algorithm I applied. Maybe there is some other decomposition. I hope this point you are understanding. See, here I have applied only one algorithm. Only this BCNF decomposition algorithm I applied. Did I check all the decompositions? Did I check all the BCNF decompositions? I did not check. Yes or no? But let me tell you. Okay, let me tell you one very interesting point. And using this interesting point, you can easily find out whether some dependency will be preserved or not. Okay, so let me tell you. So here, just look at this. See, first of all, here you can notice that look at this functional dependency. Okay, just look at this functional dependency and tell me this AB determining C. Okay, can AB, see, AB will determine C, that is fine, but can you indirectly determine C? Like AB, can it indirectly determine C? Can it indirectly, transitively, can it determine C? Let me know. AB determines C, but can AB indirectly determine C? Is there any way to indirectly determine C? Means AB determines something, then something determines C. Is there any way? Please tell me. There is no way. Yes or no? Are you getting my point? So AB determines C, and this will happen. This will happen directly, basically without transitivity. Okay, you cannot put anything here. AB determining C. This is the only situation. Means what I'm saying. Please, I am saying that if you want to preserve this dependency, if you want to preserve this FD, then you must have ABC together in the same table. Are you getting my point? Let me know. Okay, see, very simple point that, very simple point. If I want to preserve this dependency, to preserve, okay, in any decomposition, see, very simple point. In any decomposition, whatever decomposition you take, in any decomposition, to preserve this FD, if I want to preserve, If I want to preserve AB determining C, okay, to preserve AB determining C, we must have we must have A, B, C in same subrelation. Is this clear? Did you understand? Very simple that. Just notice one thing. Can AB determine C transitively? Means transitively can AB determine C? No. You can easily see here. AB cannot determine C transitively. Okay. There is nothing. Basically, no intermediate person. No intermediate. Okay. Yes or no? See, let me give you one example. For example, consider this relation R where you have, let's assume, A, B, C. Okay. And you have this type of functional dependency. These are the FDs. A determining B, B determining C, A determining C. Okay. Now just look at this FD and tell me, look at this FD. To preserve this FD, do I need to put A comma C together? Let's assume I want to preserve this FD. I want to preserve this FD. Do I need to put A comma C together in the same relation? If I want to preserve this FD, do I need to put AC together in the same relation? The answer is no. Why the answer is no? Because I can indirectly preserve this. See, I can transitively preserve this. Are you getting my point? This functional dependency I can transitively preserve. Transitively I can preserve. So I do not have to put AC together in the same relation. So very simple, to preserve A determining C, I don't need to put them in the same relation. To preserve A determining C, we don't need to put AC in same relation, in same subrelation. Okay. Yes or no? We can transitively preserve this. We can transitively preserve. Transitively preserve this A determining C. What you can do? You can you can create one relation where you have AB and you can create another relation where you have BC. Now you can transitively preserve. A will determine B, B will determine C. So you can transitively preserve this FD. So this is the point I'm trying to tell you. Please focus on this set of FD. This set of FD is given to you. Now you tell me, okay, both the FDs you look. Now you tell me, AB is determining C, that is fine. That is fine. But is it possible I can transitively determine C? Is it possible that AB can transitively determine C? Some intermediate person can you put? Can you put some intermediate person like D? Can you put D here? No, I cannot. Yes or no? So this is the point. So remember, in any decomposition, whatever decomposition I take, in any decomposition, if I want to preserve this, then we must have ABC together. Yes or no? If I want to preserve this, then ABC must be together. Now there is a problem. What is the problem? Tell me, what is the problem now? Now there is a problem. So this is clear that ABC must be together. Okay. Yes or no? A, B, C, D. And these are the functional dependencies you can see. AB determining C, C determining AD. These are the functional dependencies. We agree that if you want to preserve this, I want to preserve this. So ABC must be together. Okay. Else this will be lost. Yes or no? So to preserve this is mandatory. To preserve this FD, ABC must be together. That is mandatory. ABC, this ABC must be in same relation, must be in same subrelation. That is mandatory. Okay. Else this FD will be lost. Okay. Else this FD will be lost. Okay, correct. Now there is a problem. Now the problem is if ABC together. Now the problem is this. Let me tell you. Now let me tell you the problem. The problem is if ABC together, if you put ABC together, then this will not be BCNF. Okay, then this will not be BCNF. See, if ABC together, then this is not in BCNF. Why? Why this is not in BCNF? Because if ABC together, then You can see AB will determine C. You can see AB will determine C, but C will determine A. Don't forget C determining A. C will determine A. Yes or no? I hope you are finding this interesting that if you put ABC together, then AB will determine C, C will determine A. Now you can easily see that this is not in BCNF because this is not super key. This is not super key. Is this clear? So that's it. So did you understand that if I preserve this, then I will not get BCNF decomposition? Understood? If I preserve this FD, then I will not get BCNF decomposition. If I get BCNF decomposition, then this will be lost. So there is no decomposition, there is no BCNF decomposition which can preserve this. This is what I wanted to prove. I want to prove that there is no BCNF decomposition which can preserve this FD. If you want to preserve this FD, then ABC attributes must be together. But if you put them together, then because of this, this ABC will not be in BCNF. So finally, I can say that for this relation, there is no decomposition. There is no BCNF decomposition. There is no BCNF decomposition exist which can preserve this FD. AB determining C, this FD. Okay. So the question is asking which of the following does not have all these three properties? Okay. So finally, I can say the answer will be option C. This is your GATE 2001 question. So I hope you understood. Please tell me the complete analysis. Did you understand? Let me know. The analysis of option C, did you understand? Very simple question. Remember, just check each option one by one. For option A, we have BCNF decomposition, which will satisfy all the properties. For option B, we have BCNF decomposition, which will satisfy all the properties. Option D is already in BCNF, so there is nothing to check. Option C does not have any BCNF decomposition, which will preserve this FD. Okay, is this clear? Simple, right?